Hi, I'm Martin Bailey from Global Graphics Software, and today I'm going to be talking about the Harlequin rep. Harlequin is well known for its high speed, but speed is only useful if it's delivering what you need. So today I'm going to be demonstrating a few of the things that you can do with spot colors when processing jobs through the Harlequin rep. Let's start with a quick executive summary. Spot colors can be specified in many job file formats, including PDF, PostScript, and TIFF. Each spot separation supplied in a job file may be rendered for its own spot ink or toner, emulated in process colorants using data from the job file, emulated using data configured in the DFE, either to tune the output color or for creative purposes, output with additional controls for overprinting, completely ignored, merged with other spots, printed using a recipe of other colorants, inverted to emulate silver ink with white, exported to vector graphics for cutting, folding, etc., and a few other things. Before I dive into the demos though, it's easy to get confused if you use the same words for a color in a job file and for the specific inks or toners used on a press. So I'm going to use this terminology throughout this video. A separation is a request for a color by name in the input file. A colorant is a specific ink or toner that's applied by the press. Historically, there was an assumption that a spot separation in a job file should be printed with a corresponding spot colorant on the press, but that linkage has got weaker and weaker over the years, especially with the increasing adoption of digital presses. In a sense, that's what all of this video is about. Colors in job files can be specified in many different ways, including in device-dependent color spaces such as device CMYK, and in device-independent color spaces such as LAB, or when an object is tagged with an ICC profile. Colors specified like this, without identifying a color by name, will almost always be printed using process colorants, usually cyan, magenta, yellow, and black, CMYK, or some extension from that. When a color is specified by name, and where that name does not match one of the process colorants, then it's a spot separation. You can divide spot separations into several classes. Colors that represent a brand's identity must be reproduced very accurately, and that may justify using a specific spot ink for them. Using special spot inks for brand colors is reasonably common on conventional presses, especially Flexo. But developing and using spot colorants on most digital presses is expensive and normally only justified if you're dedicating one or more presses to a major customer with a really important brand color. In other cases, a designer may have specified a number of colors that they reuse within one or multiple designs, and they simply wanted to be able to select them easily. Just looking at a job file, it can be difficult to distinguish these from brand colors, but they don't normally need to be reproduced quite so accurately. Arguably, these would be better addressed using swatches defined in LAB anyway. Some print workflows support special colorants such as white, varnish, metallic inks, embellishments such as foiling, and anything else that's intended to be printed or added using a separate embellishment device, but represents something other than just color. There are a number of processing steps that are often recorded in job files using technical spots, such as for cut or fold lines. And finally, register marks are specified using the all separation, and usually intended just for register and maybe crop marks. I'm going to do most of this demonstration showing the PDF file that I'm rendering on the left and rendered output on the right. I'm using a PDF viewer here based on Global Graphics Mako SDK to show the PDF. It has a very convenient display that allows me to show the color breaks, the separations, within the file really easily. I'll be rendering files to TIFF just for convenience in viewing. I'll show separations and or composite output as appropriate so you can see what I'm talking about. I'm using a tool called Faststone to show the TIFF files. There are many other equivalents that I could have selected instead, but just be aware that many image viewers don't show CMYK TIFF files very well, and very few show CMYK with spots. You can see this sample PDF has a line of text across the bottom, showing the separations it's asking for. If I open one of the TIFF files, you can see there's an extra grey bar at the bottom that isn't visible in Mako. That's because it's not in the original PDF file. I'm adding it with the extra text on it as the job goes through the RIP, because it can sometimes make it a bit easier to see what's going on with different RIP configurations. The color list in Mako shows the separations requested by the job, and the list here in the grey bar shows the colorants that are actually rendered. In this case, I'm rendering all the separations to their own colorants, so the two lists are the same. As we go through these demos, you'll see each one is prefaced by a separator slide like this one. And in the top right-hand corner on these divider slides, there is a letter. Harlequin RIP evaluators and OEM partners have access to the sample files and configurations used in this demonstration, and these letters are appointed to which files to look at for each section. I'm going to start with some simple separations and emulations. So, here's a PDF file with CMYK and spots. Most spots are brand or design colors, but we also have a white. And here I've separated them to all separations. There's one colorant for each separation in the input file. And as you can see, I've got 12 in this file, which is not all that unusual where designers have used a lot of design spots. But much of the time, especially on digital press, we don't have inks for many of the spots. So now I'm going to render the same input file, but emulating most of the spots by using process inks and just leaving the white as a spot. If we had a brand color in this instead of just design spots, then we might have chosen to produce a colorant for that particular brand color. There's nothing special about white in this respect, is what I'm saying. And as you can see, if I look at these, here's the list of separations, and here's the current colorant. So this is the black output, and it's got input from a number of the separations on this one. If I look at the cyan and the magenta, for instance, I see the same thing. If I were in labels and packaging, or in decor or textile, I may have extended gamut inks, maybe adding orange, green and violet, as well as the CMYK, in order to achieve printing of more saturated colors. And I can do exactly the same here and emulate the spot colors into an extended gamut set. So now I've got black, cyan, green, magenta, orange, violet, white and yellow. And again, multiple separations from the input file having some contribution to each of those output files for the colorants on press. By default, Harlequin will use the emulation data supplied inside the job file itself. That's usually either in CMYK or LAB. If it's in CMYK, the resulting emulation could be quite different from what the designer and brand wanted, because CMYK tables for color books like Pantone in design programs are based on substrates, inks and printing processes that won't match most real-world production. If the emulation data is in LAB, then it'll be processed through the selected output color profile in the RIP, and you'll probably get something much closer to what was intended. But even so, it may not match what the brand really wants. That's why it's possible to define new emulation data in Harlequin to override the information provided in the job file itself. So if we go back to taking this file and separating it to CMYK, just CMYK, here I'm showing the separations and a composite. So here's black, cyan, magenta, yellow, and that's what it looks like in color. But in this example, the brand wanted the space background, this purple color, to come out a little bit different, brighter. So here are the equivalents with a different emulation data specified in the RIP configuration instead of using the emulation data from the file itself. I'm going to reorder the output by file name. You can see here's the original black and the new black, original cyan and the new one, the original magenta and the new one, original yellow and the new one. Most tellingly, here's the original composite. You can see that space background is rather dark and not very saturated. and with the new replacement emulation I'm getting a much richer purple color. Now in the real world, the color change that a brand will request is usually very small, too small to see reliably on this video, so I've made it much more extreme than you normally see, just so the effect is obvious. Of course, you can take this to extremes. For example, you can use emulation data to print different colorways in textile or decor from the same job file. These three outputs are all from the same job file where all of the colors have been defined as spot separations. And you can see they're all very different. If I walk through them, here's the original, and here are two different ones where we've just changed the representation of the spot colors. But be careful. Being creative at the DFE and the press means configurations are more job specific, and jobs need more process control and are harder to automate. It can be very useful for niche applications, but the DFE user interface really should be created specifically to manage and report what's going on clearly. Now I'm going to switch to another variant of the design we were just looking at. This one doesn't include any design colors as spots, but it does have separations for a cut line, a foil, and a spot white. Obviously Harlequin can deal with design and technical spots together, but it's just a bit clearer to show them separately. I'm going to start by just rendering all 7 separations, process and technical spots together. And you can see exactly what we've got on the spot layer like this. But let's assume that the application of the glue and the foiling cannot be registered very well to the color printing. The foil glue, for instance, is often rendered on a different device, or it's rendered at a different resolution, and certainly the foil is applied on a different device. If I look at the magenta separation, you can see that the foil stars have been set up to knock out of the color underneath here. So if I switch between foil and magenta, you can see that these stars here are the foil being knocking out. But if the foil is not registered well with the color, we could end up with a white line around it. Foil is pretty much always completely opaque, so let's just overprint the foil separation. We could say to the designer, take it away, do it properly, but often that's not what a printer wants to do. And if you're doing foil, it's actually quite normal to overprint it all the time, as long as you know the glue will adhere properly on top of the color inks. So here I'm going to do exactly that. I've simply adjusted my configuration to say when I print a colorant called foil, make it overprint. Again, I will reorder to link things together, and here you can see the original foil separation and the replacement. No difference at all between those two. But if we go to the original magenta, you can see the knocked out stars, and when we go to the new magenta, we can see that the stars are now overprinting, the foil is now overprinting, and we're not going to get any problems. But that's not to say that the output that we're getting now is perfect, because looking at the magenta, we're not getting the foil knocking out of it. But if we look at the white, we are getting the cut line knocking out of that, because somebody's forgotten to set the cut line to overprint. You could say, well, let's apply the same rule and just set the cut line to always force overprint. But in fact, we probably don't want the cut line printing anyway, at least for the main production run. So what I'm going to do is to tell the RIP to completely ignore the cut line. Not just don't generate a separation, a colorant for it, but ignore it completely. So I'll start by deleting the second set that we've just produced and changing the configuration slightly so that the cut line is now completely ignored. Again, resort into file name order, and we can see here's the original white that we had, which was getting knocked out by the cut line, and here's the new one, no cut line knocking it out. And in fact, if we look further up, there is only a cut line in the original. There is no cut line on the new set of rasters I've produced. While we're looking at ignoring technical spots, it's worth noting that technical marks like whites, varnishes, cut and fold lines, etc. can be controlled using PDF processing steps instead of needing to look at spot names and making a job-specific configuration. But that's not strictly speaking about managing spot colors, so I'm not going to cover it in detail here. Now I want to talk about a different kind of emulation for spots, recipe colors. Here's a sample file that might be for a greetings card, for instance. It's designed with the green stem and leaves in CMYK and the flower petals in a spot color called rose gold. We can obviously print this just in CMYK, emulating the spot color if we want. And that's fine for a basic print. And you can see the rose gold has primarily gone onto the magenta separation there. But if we want a premium print, and after all that's probably why we started off with a file that had a rose gold spot in it, we're going to want to take advantage of that spot color. So let's render to all the separations identified in the job. And now we've got black, cyan, magenta, yellow and rose gold. This is great if we happen to have an ink called rose gold or something appropriate that we can alias to as we did on the previous demonstration. But having a metallic pink ink is pretty rare. On the other hand, it's not too uncommon to have a metallic silver. And if our process inks are reasonably transparent and laid down after the silver, we can achieve a metallic pink using a recipe that uses both a silver and one or more process inks. So here we've aliased the rose gold spot to a recipe comprising solid silver with magenta and yellow over the top. So again, black, cyan, nothing from the rose on those two, but we've got 40% magenta, 20% yellow and solid silver there. So when those are printed, you will get something approximating a rose gold. So that was using a real metallic silver ink, and those are available for offset for flexo screen printing, obviously. Also for a number of printers in the wide format space, and increasingly for premium printers in labels and packaging and in commercial. But not all presses have a silver ink. And there are quite a few that have an opaque white that don't have a silver. And some of those presses can print on a pre-coated metallic stock. So let's take a look at this file. It's a sample from ColorLogic. That's ColorLogic with a hyphen in the middle, not the color management company with a very similar name. You can see that it contains graphics in CMYK and in a spot color called CL4713 silver. If we just render all the separations, we get the expected output, 5 separations including a silver. But we can easily tell the RIP to effectively print the silver as a negative and to send it to a separation called, in this case, spot white. If I resort the rasters into file name order, you can see the blacks are the same as they were before, the magentas are the same, etc. And if we look at the silver from the first pass we ran and the spot white from the one we've just done, you can see the spot white is just a negative, but now it's prepared to be sent to a colorant on press called spot white. So if I print that on a pre-coated metallic substrate, then I'm going to get a silver effect where the silver comes through the white, and all of the color is going to be printed on top of that white, so that'll look correct as well. I included register colors in the list of different kinds of spots. Register colors, or the all separation as it's called in the PDF and PostScript specifications, are used to draw things that will be painted in all colorants. And usually that's just register marks and crop marks, but sometimes it's used for other things. Here's a simple example with process and spot colors, plus the word registration in the all separation. So if I rip that to one TIFF file for each of the separations in the input file, you can see I get all of these 8 files for the different process and spot names in the original job, and the word registration appears on all of those output TIFF files. This is typically what you want when you're running a conventional press, especially for Flexo, because the registration marks are key to making sure that all inks are printed on register on the press. But if you do it on an inkjet press, you'll get 800% ink coverage on anywhere marked with the all separation, and that can lead to all kinds of problems, even with something as small as a register mark. And if you have sufficiently poor registration on an inkjet press that register marks would be useful, then you probably need a special test form to print rather than just relying on register marks in your normal jobs to figure out what's going on. So Harlequin allows you to just paint the all separation to the CMYK channels, like this. You'll notice that the grey bar at the bottom is also only shown on the CMYK channels, and that's because that's painted using the all separation too. But even with this, you've still got 400% coverage everywhere where that word registration is in the all separation. So there's one more step. You can paint the all separation in just the black channel. Next, I'm going to talk about exporting contours specified in technical spot separations as vectors. This can be useful in wide format for stickers, car wraps, etc., in labels and packaging, and in this example for promotional folder. I've made the cut and fold lines on this job a bit heavier than you normally would so that you can see them clearly. As usual, I'll start by rendering all the separations. Here we have CMYK plus fold and cut. So that's the fold line, sorry, the cut lines, and those are the fold lines. Next, I'll configure the rip to intercept anything painted in spot colors with names that start with cut or fold, and export those objects as vector. In this case, I'm exporting to PostScript for this demo just because it's convenient. The contour export is deliberately written to support adding new file formats as required, but if I export to PostScript, I can then re-render it and allow you to compare that with the original rendering from the job. As we run the rip like this, watch the Windows Explorer window in the bottom left. And you'll see a new file called ggsfolder.ps has popped up. That's the exported contours in vector format. Now, if I look at the rasters here, you'll see they're set very similar to what we had before. So if I resort as usual, you can see here's the black, original black, and here's the new black when we've exported the contours. But one interesting thing is that when I look at the cyan, this is the original, and you can see that somebody put in cut marks and didn't set them to overprint in the original design. But since those aren't real colorants, I don't want to print with them. I don't want to see white marks there that wouldn't look very nice on the final finished product. And because I'm exporting the contours, I'm actually taking them out of the data that is being rendered. So when I have exported the contours, those little marks have disappeared. I said I've exported to PostScript so that I can re-render it. So now I'm going to do exactly that. And again, resort by file name so everything comes in together. And now I can look at the original cut line from rendering the original PDF file, and the cut line from rendering the exported PostScript. And again, the fold lines, and again the fold lines. In this particular instance, I chose to export both the cut and fold to the same file in the same format, using the same rules around exporting colors, widths, and dash patterns, etc. Just because it makes for a easier demonstration. Finally, I mentioned when I was talking about controlling how technical separations are rendered that PDF processing steps can be used in alternative to spot names, and that's true here. The export can be configured to look for specific processing step groups and/or types, and to export all marks inside those. I hope this video has been useful for you. but please remember that I've only shown a subset of what Harlequin can do, and that the examples I've shown can be used for a lot of other use cases beyond what I've been talking about today. Also remember that I've only been showing what Harlequin can do. Which bits of that you need will depend on your press and on elements of the workflow that you're building around it. You can find more information about the Harlequin RIP and our other software components for building DFEs at globalgraphics.com. Thanks for listening.